procedures and policies like up front. The automation is a great way to improve security, because if you're sort of hand tweaking every single instance, there are going to be mistakes made. I mean, that's just the way it is. Whereas scripts and other forms of automation do things repeatedly. Now, it has to be doing the right thing repeatedly, but you sort of have to get it right once rather than make sure you get it right 1,000 times.
So to answer your question about sites that are outside the organization, so IBM is a customer of Red Hat who provides, and IBM provides their own cloud solutions to their customers. They're using Red Hat's technologies to provide the cloud. So does Amazon. So in this environment here, you may choose to say, hey, I want most of my systems in-house in my private cloud, but occasionally, close to a big buying season, near Christmas time or whatever it is, I need to have more capacity in my e-commerce service. Where can I get this capacity? Right. There is space available that you can rent from Amazon or from IBM or whoever else there is available in the geographical region. So that's, in this case, it's a sort of a hybrid environment. So you move out to the public cloud for a certain duration of time, and when you're done with that requirement, come back in, turn it off, and you don't pay for it anymore. When you need to fire it up. Okay? So virtualization gets you part of the way, cloud closes the gap. So in this diagram here, again, going from physical systems to virtual environments, you build your own private clouds. Okay? If you don't have a proper mechanism to manage these things as a IT-focused IT service, with a focus for IT service, like how do I automate, how do I ensure that the right people are able to get to it, how do I do self-service, how do I do backups, how do I do all this necessary stuff. If you don't focus on those components there, you are kind of missing the game. You are then writing it as a buzzword. Oh, cloud, I need to have cloud. Yes, I have cloud, check. But what does it really mean? Are you doing it the right way? In the way that will benefit you from a long-term perspective. Anything to add to that?
I think that, and really what we mean by IT service here is really trying to think about applications, trying to think about business processes, kind of trying to, and you're never going to perfectly abstract it, but particularly from the perspective of the user, getting away from thinking about systems and blocks of storage and that kind of thing to, I want my mobile web application developer space, and I need another one of those.
What is automation here? Like was explained in the previous slide. Well, these two slides, right? Automation. There may be things that you need to do on a regular basis to create systems, to manage systems, to backup systems, whatever it is that you need to do. Doesn't that come in SaaS? Yes and no. Yes, it does, because it's done by a SaaS provider, not you. But so therefore, no, it's not automatically provided, because it's provided by a SaaS provider, not your. Because you are just using it. Remember in the picture, as a SaaS, your only data is your stuff. The rest of it is done by them. So there's a difference in that sense. Okay.
Yeah, we haven't really gotten into why you would use one of these versus another. Software as a service, what we're typically seeing the interest in is, given the Salesforce.com example, email, payroll, business financial benefits administration, basically things that, for most businesses at least, now, obviously Amazon's customer relationship management system is pretty core to their business, but for most businesses, those are things that they need to have, but a company is probably not going to win in the market because it has a better payroll system than the company down the street. Now, if they don't, pay their employees, that's going to be a problem. They do need a system that works. I don't mean to imply it's unimportant. And also, one payroll system pretty much looks like another payroll system. So those are the types of applications that tend to go to software as a service. More typical core business applications tend to require a greater degree of customization. So saying that one manufacturing system, inventory system fits all doesn't tend to work very well. There also tends to be a lot of integration with other pieces of software. So yeah, there's automation going on below the top layer, but it's whatever the SaaS provider provides you, sort of take it or leave it. Whereas the kind of automation we're talking about here is, for example, I as a developer select a mobile web development application or development environment from a service catalog, and the system, the automation system, sets the right security policies, deploys it to wherever the policies have established it can be deployed to, sets up firewall ports, does all that kind of stuff. That's the kind of automation that we're talking about here.
I'll answer the question. Was there a question here? Yeah.
So I was just trying to relate it to the point about value proposition. What we want to talk, will this actually help make sense that the in-house IT managers who use the cloud as a way to position that if it is difficult to forecast the demand, this is where external cloud help to buffer those things, but we also know that going external will be a premium. So we're also giving a buffer time for you to forecast the resource and demand for which you start building up the internal so that you can help exploit the demand.
That's a good way to analyze it, yes.
So the crowd, that's where the value proposition comes in, because you never been very accurate. But how you actually address the buffer which the external cloud comes into play.
Yeah. And one of the advantages of an external cloud is you know how much it's going to cost you. It is usually metered.
You know how much you actually pay.
Yeah.
It's time to actually bring back.
That's right. That's right.
Yeah, no, I dealing with unpredictable demand to a degree that the application can run a public cloud. That's absolutely one value proposition. In general, the fact that your developers can self-service and get a development environment up and running quickly as opposed to having to requisition a server. Faster application development, less red tape, that kind of thing. I think one point, and I think you sort of touched on it here, is although a kind of cloud very much has an efficiency element, kind of doing more without having to add a lot of people, it's really not about, virtualization kind of came in because it's about utilization, buy fewer physical servers, save money. I really look at cloud as more about how to do more without having to, hire 10 times the number of people in order to do it. I mean, there's actually some data I've seen from analysts are very interesting. They talk to companies who are implementing clouds, private clouds, and they found that, the answer to why are they doing this are very much about accelerating business, growing revenue, making their IT more strategic. Is not about getting rid of some admins and saving money.
It's got to do with time to market as well.
Yeah.
I mean, if you look at, again, to go back to your question about what's the value proposition, right? The value proposition of cloud is, if I need to, if I'm in a business, I need to quickly respond to my competition. Or because, suddenly my competition is able to send SMSs out whenever they meet in a book. I'm in the book industry. And I want to be able to, hey, can I provide that service as well for my catalog? Okay, how do I do that? Oh, do I have to buy machines? Do I have to do all this additional stuff? That's not going to work. That's not going to be a quick response. So this is a way for you to acquire quick services. Maybe within a week, you have an application running and you respond to your competition. So time to market becomes your value proposition. And at some point, the fad about sending SMS when you read a book may disappear. At which point, turn it off. You didn't acquire that stuff and run it internally. Right? So these are the ability to respond to this business requirements is a clear value proposition. Yeah, sorry. So at the end of the day, great that you have all of these wonderful ideas about virtualization, about cloud, about private cloud, about public cloud. There's this idea of portability. How can I move from one environment to another environment, not necessarily within the private environment? How do I make it portable? Because the last thing you want to do is to be stuck in a vendor lock-in situation. You get locked into a cloud service provider. That, as the CEO of Red Hat has said before, the cloud can be the mother of all vendor lock-ins. You are locked in and you cannot get out. It's like Hotel California, right? You may leave, but then you never left, right? Something like that. So it's a huge problem. We need to address that now, before you get into the cloud. So here, this picture shows a steering wheel. I think this is from the 1950s.
I think somebody in my road tour, I think Chicago, whose father had been a GM engineer, tells me this in 1956 Chevy.
Okay. So, you look at this, we drive on the other side of the street. I can still drive this car. The steering's the same, the pedals are the same, everything remains the same. Yeah, it's on the other side of the car, but it's the same way of driving. Everything remains the same. It's portable. My skills are portable. Right? That is important. It's important from it may seem simplistic, but it's very important from an IT perspective. Your systems must be portable. Your skill sets must be portable as well.
I guess this is manual, right?
This is manual, yeah. It's a stick shift. I see the stick shift there.
There's a shift, and it's actually not a shift, and you need to have that.
It's
Well, actually, there definitely were American cars with manual sticks and the steering wheel in that time frame. I'm not sure what that is, but it's probably a stick.
That's a security device. I see the next for the car. So why does portability matter? Right? This is a quote from Gary Chen, who's a research manager at IDC. We found that, I just read out the second line. It says, we have found that open APIs and interoperability are essential for customers considering the cloud. If your APIs are not open, you cannot get in and out of a cloud service provider. That becomes a huge problem. You are then locked in, you're stuck. And Red Hat last year, the year before, introduced this idea of a cloud foundations. And the idea behind it is to be able to create portable environments using a notion of Delta Cloud that allows you to move from cloud service provider to cloud service provider without the danger of being locked in. So let me move on to something that we announced recently, OpenShift.
Sure.
Do this?
Yeah, so I think without maybe using the term very often, what we've sort of been talking about predominantly here is infrastructure as a service space. And we announced a open source software product that you saw driving from all those open source projects called CloudForms at our summit in May. And that's our infrastructure as a service product. It's in beta now, and it'll be rolling out over the course of this year. And that's some little kind of a traditional Red Hat product in the sense that it's open source software, be available by subscription, medium to large IT organizations will install it on-premise to manage their private and hybrid cloud environments. We also announced something that's kind of new and actually pretty exciting because as I think I mentioned earlier, there's a lot of activity in the platform as a service area, but it's still developing. So there's really a lot of opportunity to to kind of move it in directions that are beneficial to our customers, and that hosted platform as a service offering is OpenShift. Basically, so it's available in 3 different flavors, if you would, for right now: Express, Flex, and Power. There are developer previews of Express and Flex available today. You can go to, I think it's upshift.redhat.com, give it a try. It's free. And basically, going from left to right here, you're adding complexity but gaining control. It's just fairly typical trade-off. So what is OpenShift? Well, OpenShift, first of all, gives you a choice. You basically choose whatever language you all develop in. I'm not sure what all the current list is, but basically the idea is that develop in PHP, Java EE, Ruby, Python, a variety of different frameworks that you can use. But pretty much really serve your choice. So this is different from a platform as a service that has, for example, APIs to a specific proprietary database implementation. The OpenShift then, which is a hosted service, then gives you some application management and monitoring. In the case when you go up to Flex, it gives you auto scalability and those kind of features in the application. And then those can be deployed to the cloud of your choice, any supported cloud. So the idea here is that OpenShift provides platform services for your application, but you can write that application in the kind of development environment of your choice, deploy it to the public cloud provider of your choice, and really all we're doing is providing some application services. So you can take that application that you've developed and move it to your own private cloud. Obviously, at that point, you lose whatever application monitoring and so forth OpenShift was providing for you, but the application, you can continue to run it on-premise unchanged. And that's a pretty big difference from a lot of the other platforms of service approaches out there, which are really, you have to run it on our particular PaaS provider. Suresh mentioned Delta Cloud earlier. That's what we use in order to basically run on a number of different clouds. So this is our API, sort of a modular API that talks to a number of different clouds. This is actually an incubator project in the Apache Software Foundation now, so Red Hat does not control this. We felt it was important that an API for cloud be under the governance of a very well-established and well-regarded organization that isn't controlled by any single vendor. Because we felt that was really what was needed in order to make it completely open. And OpenShift then leverages all of these other technologies. But this is infrastructure that is abstracted away from you, at least with the Express and the Flex offering, because the idea here is that we will provide a very easy on-ramp for open source developers. You just write their application, PHP or whatever, type a couple of lines at the command line, and their application is up and running in the cloud. So they're not having to configure a Linux server and set up a PHP environment and do that kind of thing. So they can just write their application and fire it up there, and with the things like the flex service will even take care of scalability for you.
Just one thing I want to add in this slide is the Delta Cloud. I just want to emphasize the fact about the Delta Cloud. Delta Cloud was a project Red Hat initiated with the view and understanding that if you are going to be running a system in a cloud, and so you're acquiring something from a cloud service provider, at some point you may want to move to cloud provider B from A. How are you going to move across? What are the tools and techniques available? There are none. Recognizing that that is going to be a significant issue, what we initiated was this notion of a Delta Cloud to provide a series of APIs that allow you to move from cloud service provider 1 to provider number 2. Now, naturally, if this is only driven by Red Hat, the adoption may not necessarily be as widespread as we would like it to be. So we made this conscious decision as part of the open source community and how we do stuff. We donated the entire set of techniques and technology over to Apache Software Foundation. They're the same guys who brings you your Apache web server. So ASF owns this today. And it has since taken on a life of its own, and a lot more people are contributing ideas and code and stuff like that is reaching a certain degree of maturity. And I probably can mention it here as well that Delta Cloud is now being considered as a prerequisite from a standards perspective, from a US government perspective, to have as a prerequisite for any cloud provisioning from a US government perspective, US government rollouts. If you don't have a Delta Cloud kind of API set, that's not a cloud that you want to connect into, because you've got no easy way to get out.
So the way this is also make it to be accessible by any client that has either from IE to...
Oh, it's got nothing to do with the client access perspective.
It's a way to access it as an application.
Yeah, it's actually a REST. In terms of how Dell Cloud is accessed, it's actually a REST API. And there's also, there's a bunch of clients written in different languages as well. So it's actually this sort of modular architecture that you have this REST API and clients written in a variety of languages on the input side. On the output side, there are things called drivers that are written. They can be that any cloud provider could write their own driver for Delta Cloud, and then there's kind of the core mapping technology and other code in the middle of Delta Cloud. But this is modular, so you can write a client without affecting the Delta Cloud core. You can write a driver without affecting the Delta Cloud core. So again, in the kind of open source approach, one of the things about open source that we found is that when you can provide that modular type of approach that lets somebody develop something that they need and do it in a fairly modular, independent way, that's a lot easier than if they have to go into a core, than if they have to go into, a big monolithic stack of code.
So it's got nothing to do with the browser side of the game. It's got to do with how your systems are going to be accessing different environments, moving across. The browser part that's standard HTML in that perspective, or JavaScript. It's got really nothing to do with IE or whatever. So I'll just flip through the next few slides. These are basically some customers that we thought would be useful to mention. And the kind of customers these guys are. I mean, NTT Communication, they are very large, one of the largest guys in Japan. And when they wanted to get into a cloud service provisioning system for their customers, they chose Red Hat's technologies, which is essentially built on open source stuff. They felt this is good enough to be able to deploy and provide as a service. Another customer, Dreamworks. This is where a lot of the movies are being rendered. Shrek and you name it. Almost every movie that comes out from Dreamworks is running and is being rendered on environments that is running a Red Hat virtual environment to do the massive amount of rendering that they need to get done for movies that they are making. And we work with them, and a lot of the ideas that they create for their requirements eventually finds its way into the upstream kernel, so that everybody else benefits as well. Not only them, not only us, also our customers and our friendly competition. Okay. The defense agencies. These are similar to our DSDA. They use this extensively for their own internal cloud provisioning. Now, clearly, there's a lot of good deployments out there that uses the cloud for their own internal. Some of them are private for their own purposes. Some of them are providing it as a service to the customer. So, our vision from a cloud computing perspective is essentially to create the data center of the future starting today. The data center of the future is really virtualized. It could be anywhere. It could be somewhere, as Google's one is at next to Columbia River, in the northwest of the United States. Anywhere there's cheap power, that's where your data center will be. And you connect it via the cloud, via broadband, via high-speed networks, via the next generation broadband networks, whatever it is, right? It must be open, it must be interoperable. If it is not interoperable, you are asking for too much aid. Not now, but at some point in the future, when you need to exit, you need to go out and do something else elsewhere. There's going to be a significant amount of aid that you are not therefore going to be able to do the best job you can. Preserving your existing IT investments. The last thing we are going to tell you is to throw away what you have. No, that's not what we want to do. We want you to make sure you get the best and most out of what you already have invested in. Sometimes some hardware may not work, then maybe it's time to retire it. But let's be careful about what you are going to retire and what you're going to be reusing. And we want to be able, you to be able to reuse as much as possible. And at the end of the day, it has to be built on solid infrastructure. Infrastructure that does not compromise. Security, fundamental across the board. No questions about it. Is there anything you want to add? Maybe, okay, let's see, I think I have one last slide and that's about it. But what I'd like to do is to go back to those questions there. Let's see whether we answered any one of them. Or none of them. Alright, let's see. The first one is about security, data privacy, and protection. What have we mentioned about that? We'll ask questions on that one. Are you sufficiently okay with that answer so far from a security point of view? SE-Linux, SBIRT, making sure you lock down your virtual machines?
Yeah, I mean, then there's a lot broader questions about privacy and so forth, and probably a little bit out of the scope of this.
Some of it is got to do with policy and how you do stuff and all that, right? Yeah. Value proposition on the cloud, I think we covered that quite a bit. Healthcare and patient records in the cloud. That's got to do with, to a certain extent, with making sure you get the right privacy policy, plus treating it as a hybrid cloud or a community cloud, as you were mentioning, a community of hospitals, for example. How do they manage security? Although the HIPAA is a US act, we do actually implement some of those things here because we have the requirements are pretty much the same. Now this one, number 4, broadbandless access to the cloud, filtered internet and the cloud. That's going to be a tough one. I'm not sure there's an easy way to answer this question. Well, yeah, I'm sure the technologies are there. It's a question of whether or not it is available at the time when you need it. That's always the question, right? It's not which technology is it, but whichever it is it there at the time when you need it?
Yeah, and I do think that there is a general issue for application developers and the like, particularly when we're talking about putting intelligence into a cloud, whether it's for enterprise apps or whether it's consumer, and making the assumption that access is just there, and that may not be a good assumption.
So, and whatever you design and deploy, keep this in mind. Test this. Make sure that it's reasonably working, reasonably in a slow network environment. I think that's the fallacy that we have to, get away from, saying that once I deploy, it's always working everywhere. Video in the cloud. Is that YouTube? I'm not sure what I'm going to say about this one. Is there anything to say on video? Did I? The person who asked the question is not here. Okay. Benefits to the home user. That's a good question. I don't know. What would the benefit of cloud be to a home user?
Well, I mean, the home user, I think, again, that's cloud more in the kind of consumer cloud context, something like Apple iCloud, having this centralized repository of data, maybe you don't need to worry about being an IT admin at home any longer, but, you do have to think about, privacy, protection, what happens if the cloud provider fails, what happens if you can't get access. So not necessarily easy questions to answer. There are a lot of potential benefits there, but there are downsides also.
Maybe I just rephrase this.
Yeah.
Not these days, technology have advanced to a point that what was your PC is like a server for this. So if the home user had that capability, you can have all home users get connected from this server.
I would probably argue the trend is in the opposite direction, namely that home user devices tend to get rather stateless, like iPads, for example, and that the syncing and the processing is done more, and certainly the state is stored more and more up in central servers somewhere.
Okay. Implementing corporate, I think we kind of touched on it. Cloud.edu, education in the cloud. I mean, clearly, that's a great place to have a lot of work to be done. I think I guess the question here is more about content, about how you teach, how you make material available to students. Was there anything else that you want? Who was the one to ask this question? Someone from there. Yeah, you got to follow on to that.
Yeah, I was thinking how feasible is it for cloud to be implemented in a highly dynamic environment?
How different would it be from business? It's also highly dynamic in an education.
I think the user population tends to be more transitory, and therefore a lot of things like virtual desktops and students along will bring their own devices even more so than enterprise. So things like a public cloud-based email type of system probably makes more sense there. So I think that there are a lot of opportunity. And then in other respects, a large university is in many respects just like a large business in terms of internal IT requirements.
Okay. Regulating cloud computing. Well, is there a regulator here? IDA. I guess this is an open question. I don't think any thought has gone into this thus far. Standards for cloud. I think I mentioned Delta Cloud earlier. That's a form of pushing the development of standards so that you can have interoperability and all that. Fundamentally important from our perspective, and we hope that you will appreciate that need to have interoperability. But standards work is still ongoing. There's a lot of work that needs to be done. A lot of work has already been done in other spheres. What we need to do is to bring them into a cloud environment.